Hello there and welcome to a new video. In this video, we are looking at converting from magnitude bearing to column forms. And I do hope that all the others that we have done so far has been helpful and then you do understand. Without much I say, although let's quickly look into how to do this here. So when we want to convert from magnitude to the column form, it means the bearing has been given to us in a form that you can see its magnitude and the bearing. You see, the vector has been given to us in that form. An example is what I'm going to write over here. So let's say we have vector AB. So vector AB, which is written in magnitude bearing form as 6 kilometers 90 degrees. How would we be able to write this here as a what? As in column form? So you would need your graph sheet and then a pre-knowledge of what? Bearings. And your protractor as well. So since our book is so small that we can't draw a 6 kilometer, what we do is we use the scale. You see? So I'm going to use the scale for every 1 centimeter. Let's represent it with what? A kilometer. Now, after being able to state that every 1 centimeter on your graph here represents a kilometer, you'd now come and then draw what we call your bearing. You see, and from the question, it says the bearing is what? 90 degree. So over here, if we have to put our north up here, then how are we going to get to the 90 degrees? Certainly 90 degrees is on the x-axis. So we locate that. Over here is where we have our what? We have our 90 degrees. So for this, there's even no need to just draw. We just indicate. So this is my 90 degrees. Then now we measure 6 kilometers. But on our scale here, we said a centimeter is a kilometer. So I'll come here and then come and measure my 6. So we have our 6 being drawn nicely. That is from the 0. So from 0 all the way to what? 6. And that is all. That is all. Very, very what? Simple. So this here is our vector. You see. Now let's look for the coordinates of the vector we have drawn. We are looking for the coordinates of the vector we have drawn. And if you look at it carefully, it is on the x-axis. So it means it has no y coordinate. You see, it has no y coordinate. So this simply means that our AB is going to be what? On the x. So on the x over here, on the x, it ends at 6. You see, so on the x, it has what? 6. And then on the y-axis, it actually has nothing. You see, so on our y-axis, it has nothing. That is, we have 6, 0. This here is going to be what? Our representation in the column form. Very simple. All right. So if you want to represent a magnitude bearing form into column form, all you need to do is what? Take your time, draw it with the appropriate, what do you call it? The appropriate scale. In which case, or in this case, we use what? 1 centimeter is to a kilometer. And then based on your scale, you look at the coordinate of your drawing and that becomes your column form. So let's do some more examples to enhance our understanding. So this second question says we have to convert UV, which has what? The magnitude bearing from 7 kilometer 120 degrees into its component form. So we are converting from the magnitude bearing to the component form. Once again, we are going to use the same method. First, get your scale. Over here, I've written 1 centimeter is what? A kilometer. So with this scale, I'm going to use that to get my what? Component form. So first of all, we need to measure our 120 degrees from the north. You see, you measure 120 degrees. So I'll come back here to my graph or my Cartesian plane, which is also my cardinal, and then draw my 120 degrees. So with my compass, with my protractor, I'm going to do that. We are measuring a 120 degrees. And looking at it carefully, I would zoom so you see where my 120 is going to be. As you can see here, I am using my inner calibration. So my 0 started up there. It came all the way, and then I have my 120 here. All right. So I'm just going to use dotted line to note that out. This here is my 120. Okay. So 120 noted. Now the second part that we need to pay attention to is the magnitude of the vector we are trying to draw. From the question, it says its magnitude is what? 7 kilometers. We have already said our 1 centimeter is 1 kilometer. So we just come here and measure 7 centimeters. You see, so on what I have drawn, let me zoom that as well. So I'll just measure a 7. It appears my 7 will go outside, but let's just manage that, and then we see what it's going to give us. So I'm going to use a thick line this time around. So from this point all the way down, measuring what? Let me use a red color. Measuring 7 centimeters. So from 0 to what? 7. This is what I have over here, right on my 7. So this becomes my representation on the what? The Cartesian plane. Take note, you measured 120 degrees. So you would have to just put that here nicely as your 120. So 120 degrees. But the most important thing is what this point represents over here. You see? So you trace it to your x and also trace it to your y. Unlike the previous one we did, that was only on the x-axis. This time around, we can get what? Both x and then y components. So I'm going to trace it all the way up. And as you can see, it touches 6. And if I trace it all the way to my left, it will touch a negative 3.5. You see, so that sums that up. We have 6 on the x and then negative 3.5 on our y. Once again, after plotting per your scale, our scale we said is what? A centimeter is to a kilometer. So per our scale, this is what we are going to get. And if we look at it carefully and then trace out x and then y, realize that on our x we are getting what? A 6. A positive 6 for that matter. And on our y we are getting a negative 3.5. You see? So we are coming to write that out. So we'll say this implies that, so this implies from our graph that UV, our UV, which was given as 7 kilometer 120 degrees, in its component form is what? In its component form is 6, then our negative 3.5. Let me just write it in a column. So 6, negative 3.5. And this becomes our component form or column form. Very simple. So to sum it all up, if you are given a vector in its magnitude bearing form and you want to convert it into its component form, draw the vector with respect to your scales. Then you look forward, you trace it out to its x and then y coordinate. And then that becomes your what? Your component form. So I'll write out some questions you can try on your own to test your understanding. So on this screen, you have some questions you can try your hands on, which is express the following vectors in its component form. You have AB, that is 50 kilometers, and it is 180 degrees away from the north. BC, 5 kilometers, not 50, so 5 kilometers. That is also 225 degrees away from the north. And then CD, which is 7 kilometers, and it's 360 degrees away from the north. That is actually even 0 degree, 000 degree. So there's how far time is going to permit us. If the video was helpful, you can always like and then subscribe if this is your first time, and share as well. Stay tuned as we learn more about vectors. If there's anything you would want me to know, you can always let me know at the comment section and I'll address that for you. So thanks for watching, and then do have a nice day. Bye.